Okay, today we're working on factoring, which I'm sure you've seen in Algebra 1, whether you mastered it in Algebra 1 or not. That's a different story. We're starting out with easier questions and then building from it. So what we're covering in one day today would probably be what you would cover in like a week or two in Algebra 1. So it's kind of just quickly reviewing it, making sure it's like fresh in your head for Algebra 2, and then building on it as well. These problems might be more complicated than what you saw in Algebra 1. So factoring, what factoring actually is like when you take an expression like, let's say this, x squared plus, I'll just use it for 7x plus 12, and then you break it into two factors like this, and then you'll get like maybe x plus 3, x plus 4, and these are your factors. So that's what we're going to be doing today. It's like FOIL backwards. If you wanted to check your work, you could just FOIL this out and just first, outside, inside, last, and then you'll get the original. You'd combine like terms and you'd get the original. So that's what we're doing today. We are working backwards from FOIL to get the actual factors. Again, starting with the easy examples here, easy factoring. Easy factoring is when you don't have a coefficient in front of that x. That would be the easy factoring. So what you would do for this first problem is you'd set up your parentheses like this, your two factors. Your first term is x squared, so you'd have an x here and an x here, so x times x is x squared. That's easy. And then these two latter terms are what are a little bit tricky. You're looking for two numbers that add to this coefficient and then multiply to the last constant. So we're looking for two numbers that add to this, multiply to 12. The two numbers that come to mind would be 3 and 4. 3 plus 4 is 7, and 3 times 4 is 12. So then once you have these two numbers, just add them to x like this, and there are your two factors. And again, you could FOIL it out to check it, and you might notice that's the same example I just did with you. But you could FOIL it out to check it, but the answer is just these two factors. Okay, so for number 2, repeating that same process, we need two numbers that add to this and multiply to negative 15. So I'm thinking 5 and 3 for 15, and then if I make that negative 5 positive 3, then it would add to the negative 2. So negative 5 times 3 would be the negative 15. Negative 5 plus 3 would be the negative 2. So these two numbers I can use in my factors. So setting it up, just x, and then minus 5 plus 3, and there are my factors. And just so you know, they are factors. They can be put in any order. So in this case, x plus 3, x minus 5 would also be correct. That's the same thing. Then for number 3, continuing the same process. Two numbers that add to this and multiply to 9. 3 and 3, but for it to add to negative 6, I would need negative 3, and then when I multiply those two negatives, that's how I'd get the positive 9. So x minus 3, x minus 3. If you're looking at answer choices, I think this is what Harut's about to say. Yes, this would also be correct. No, somebody in the last class said that too. Yes, if it was multiple choice and this was in the answer choices, yes, this would be correct.
She's learned the questions you're gonna ask before you even ask them.
Yep. Okay, continuing. Now it's gonna start getting a little bit harder. These were the easy ones. But even though it's getting harder, we have methods to make it easy, which is nice. I remember when I was in school, when we were factoring these, it takes a little bit more guess and check. But the way Miss Adams taught it is she eliminated the guess and check by giving an actual process to find the factors. So just like with the other ones, we're looking for two factors here, but because this isn't just x and x, it makes this a little bit more complicated. Like, where do you put the 2x and what are the factors over here? So the method to figure out which numbers to put is we're going to set a table up like this, A, C, B. And what this means is if you look at standard form right here, I have it up here. You have the coefficient here is A, then the coefficient of your middle term is B, and then C is your constant at the end. What we're going to do with this chart is multiply a times c, so 2 times negative 12 is negative 24. B is 5. And it seems like a lot of steps at first, but I promise, like, once you've practiced it a couple times, it's pretty easy. Then we need two numbers that multiply to this and add to this. So I'm thinking 6 and 4 doesn't add to 5, but 8 and 3 could add to 5. So how about positive 8 and negative 3? Positive 8 and negative 3 would add to 5 and multiply to negative 24. Now what? Now I'm going to put 2x here and 2x here. And you might be saying, no, 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 you can't do that because that would be 4x squared and that, yeah, just put it there for right now. Put this coefficient in both spots. Then we're going to add 8 and subtract 3. We're not done yet. Okay, now that we have this set up, you would divide by a common factor in either or both of these. So both of these terms can be divided by 2, so I'm going to simplify it by dividing it by 2. So I'd get x plus 4 and 2x minus 3. Now here's my factors. I might rewrite it. The coefficient in front is normally how it's written. Well, I don't have a common factor. I can divide it over here. I'm not really using, like, it's just a method to find the factors. Honestly, I'm not really sure why it works, but it does. And it eliminates the guess and check.
Does the 2x have to be before the 4 plus x? Or like you switched it?
Yeah, I did, because this is, like, more proper. It doesn't, I mean, it would come out to the same thing. Okay, so just repeating the steps at this point, and again, once you get to the second or third example, it's just going to come out easy. So number 5, same idea. Let's just set up our little chart, ACB. A times C, 4 times 3 is 12, and B is 7. I need two numbers that multiply to this and add to this.
4 and 3 and 4.
3 and 4, perfect. And then I just write it out here. Put in 4x, and 4x, 4x plus 3, and 4x plus 4. And then I'm going to simplify this factor by dividing by a common factor, greatest common factor. So you have 4x plus 3 and x plus 1. And there's our answer. Well, I couldn't do it on this one because 3 isn't divisible by 4. So I was just pulling out any common factors. And then once I get this, you could check it using FOIL just to make sure it equals your original. And it does. Okay. Practicing it again. Same process. ACB. 2 times 6 is 12, and then I got negative 7. Two numbers that multiply to this and add to this one. Negative 3 and negative 4, yep. Negative 3 plus negative 4 would be negative 7, and negative 3 times negative 4 is positive 12. Then writing it out. And then pulling out any common factors, which in this case would be 2. And we done. Okay, repeat. And I had scheduled an extra day of practice on this, by the way, as well. I don't know if it'll be tomorrow or Monday or what the deal is. Guess we'll find out. It's funny because I'm actually like feeling like I'm ahead planning wise, and now we're don't know. Yeah, so I gotta replan, but that's okay. Okay, 7, same process. A, C, B. So 15 times negative 8 is negative 120, and then B is negative 2. Two numbers that multiply to this and add to this. Correct. Specifically, 12 and 10 for 120, negative 12 and positive 10 to get the negative 2. Okay, so I wrote this out. In this case, both of them can be divided by a common factor. So this we're going to divide by 3, and this one we're going to divide by 5.
So when we do that, it's just like simplifying it?
Yeah. Okay, so that's the secret method. That works. Actually, that's the simplest method I've found other than guess and check can be frustrating.
I was gonna ask, like, what is, if this one's, like, what is the whole guess and check?
You literally just like sit there for not hours, but like as long as it takes. So if you had this, you would maybe try out 15x and 1x. And then you try out two numbers that multiply to 8. So maybe negative 4 and 2. And then you just sit there and all day. And then you FOIL out each time. Yeah. I don't know. This method is pretty short though for this. Okay. So now we're going to build on this. Moving on to the other side. Well, it's not really built. Okay. You can do it. Like I said, I had planned an extra day. I don't know if we're losing a day. I don't know. Okay. You can do it. You can do it. Okay. So we're going to continue practicing, but adding one more type. So the one we're adding is difference of squares. You may have seen this in algebra. So difference of squares, here's the format right here, a squared minus b squared. And then the way you would factor that is just like a minus b and a plus b. What does this actually look like? Well, let's say we had something like this, 4x squared minus 25. Now look at this, both of these terms has a square root. So square root of 25 would just be 5. Square root of this would be 2x. Like the square root of 4 is 2 and square root of x squared is just x. So the way I could then write this is 2x plus 5, 2x minus 5, and there's our difference of squares. And that's how you do that.
I think I got it.
Do you want me to do another example? Okay, let's see, 16x to the 4th power minus, oh, sorry, didn't realize I could do that. Okay, so, like I said, he just asked for another example. Let's say we had 16x for, I'm going to make it more complicated, y2 minus 64. Okay, so in this case, I'd be looking to see if each of these had a square root. Square root is 64, I know that's 8. And then here, look at each term individually. So square root of 16 is 4, square root of x to the 4th power would be x squared, and square root of y squared would just be y. So I do have a square root for both of them, and I could just put 4x squared y plus 8, 4x squared y minus 8. We'll practice.
Let me write that real quick.
Okay.
Oh wait, actually no, I did write it. I just didn't add the parentheses.
You can do it. This is from Algebra 1, by the way. Is it not ringing a bell?
No, I've never seen
I had
this
a terrible
before.
teacher.
I had a really bad teacher.
Okay. I'm trying to keep the standard high while also like accommodating you guys. Okay. So then we have this chart which will come in handy. So when we look at each one of these, there's different ways we can factor these out. First thing we're going to look for is if there is a common factor in both of the terms. So for example, for number 8, just looking at that, we can divide both terms by 5 and x. So 5x, we're going to like factor out a 5x out of that, which we'll get to. So we're looking to see if we have a common factor. Or like number 11, we can divide all three of those terms by 5, so we're going to take that common factor out. Okay, so we take out the common factor if there is one. Then we look at whether it's 2 or 3 terms and decide what we're doing from there. If it's 2 terms, we look for difference of squares. Can you take the square root of both of the terms? And if you can, then you do this. If you can't, then it's already simplified, like we're done. If it has 3 terms, you're looking for whether it's an easy problem or the ACB method needs to be used. So for easy, it would be like x squared plus 7x plus 12, where you don't have a coefficient in front of the x. And then for the ACB method would be when you do have a coefficient, like 2x squared plus 5x minus 12. And then you determine which method you're using to factor it out from there. So this chart is our friend. We're going to use it. Number 8, again, looking to see if we have a common factor in both of those terms. 5 stands out to me right away. I can definitely take a 5 out, but I can also take an x out. Both of the terms have an x. So I'm taking the 5x out and then just dividing both those terms by 5x. So this would then be 3x, and 5x divided by 5x is just 1. So we get this.
That's the answer.
That's it. So we took our GCF. It's 2 terms now. We're looking to see if we have difference of squares. I can't take the square root of 3 or x. So I'm done. Then number 9, looking to see if I have a common factor there. I don't. Then I'll look for, it's 2 terms, so I'm looking for difference of squares. Can I take the square root of both of those terms? Yeah, the square root of x squared would be x, square root of 64 would be 8. So then I can write it like this, x plus 8, x minus 8, and we done, bro.
Do you have to do the -8 because it's a -64?
Yes.
Yes. And if you FOILed it out, it'd come out to that too. Like if I FOILed this, I'd get -8x plus 8x minus 64. The -8x and 8x would just cancel. So yeah, we're good.
Got it.
Okay. Number 10, looking for a common factor. 4 and 25, nada, nothing. So then I'm looking for if it's a difference of squares. Can I take the square root of both of those? And I can. 2x squared would be the square root of that. And here I'd have 5y. And then I can write it 2x squared plus 5y and 2x squared minus 5y. Who is their music blaring? Am I not interesting to you? Who is it? Who are you? Somebody who can't hear me? John Cooper! Is that you? Oh man, that was mean then. I'm sorry. Did you think it was John too?
It was like rock music or something.
I do not hear anything.
It just went away, I think.
Ooh, oh, that's
Who are you? Is Julian from way over here? Put your AirPod away.
So, okay,
dude, and you and your restroom is 10 times smaller.
No, we're gonna finish first. Can you hold it for 5 minutes?
yeah.
You're okay. Sorry. Okay, number 11. Let's get through this. Looking for a greatest common factor with these 3 terms. 5 stands out, so I'm factoring a 5 out. 5, get x squared minus x minus 20. Okay, now I got an easy, like the easy version to factor. I need 2 things that add to this and multiply it to this guy.
4 and 5.
C, 4 and 5, but -5, 4, right? So -5 plus 4 would give me the -1. So then I got 5x minus 5, x plus 4, and we done. I could really use a day off tomorrow.
If we don't get tomorrow, I'm just gonna take the day off.
Why would you do that?
That would be cool.
Number 12, we're first looking for a common factor, and both of those terms can be divided by 3. Do you know the hack to figure out if that's divisible by 3?
No.
Okay,
You add it together.
okay, yeah, so I don't know if you've heard of that hack, some of you might have. If you can add 7 plus 5 together, we would get 12. If 12 is divisible by 3, that means 75 is divisible by 3. It's like a little hack to figure it out without having to do the whole.
Yeah.
Just add 7 plus 5. If like 12 is divisible by 3, then the whole number will be divisible by 3. Life hack. Like, try it with 21. 2 plus 1 is 3. Yeah, okay, sorry. Didn't mean to get too sidetracked, but that will help you save time in your life. Okay, so taking out a 3 out of both of those terms, I get this. So I got a 2 term. Do I have difference of squares? I could take the square root of x and 25. So yes, so then I'd write it out x plus 5, x minus 5. Why am I saying 5? I don't know. British or Australian, I don't know.
Can I hear a joke? Why did British people not pronounce their
Or maybe
T's?
New Zealand.
They don't drink it all because they drank it all.
13. 13, I'm looking for a common factor. I got nada. Then maybe difference of squares. The square root of 9 would be 3. I can do that. Boys, stay focused. Maverick.
Matt, I didn't.
Yeah, Maverick, stop talking.
Yeah, stop talking. For real.
What?
Don't make fun of British people. Okay. The square root of this, I'll just take each term individually. I got 4. Square root of x squared is x, and y to the 4th squared would be y squared. So then we got 4xy squared plus 3, 4xy squared minus 3. Okay, next. 14. Oh, should I zoom out so somebody can finish up that one? 14. Looking for a common factor I can take out. Looks like all those are divisible by 7, but taking it one step further, they all have x's in it. How many x's can we pull out? We can pull out 2 x's from each of them. So we're pulling out 7x squared. And then we're left with 2x squared minus x plus 3. Okay, so now we have one of the ACB problems. 2 times 3 is 6. B is -1. I need 2 numbers that multiply to this, that add to this.
2 and 3.
How do you know when to use the table?
We have to factor.
Oh, when you have the coefficient, it'll be one of the harder ones, and you have to use the table.
Gotcha. If it's 2x, if it's like a number x squared,
Mhm.
use the table.
Yep.
Gotcha.
Okay, you're saying 2 and 3. That wouldn't work. Maybe 2, -3, but that wouldn't work either.
And then
Where'd you get the -1 from?
it's -3 minus.
B is -1.
Oh, that's the addition side.
There are no 2 factors that multiply to this to add to this, so this is not possible.
You can write that.
Possible. Can't factor anymore.
So I would have just thought I did it wrong. I hate.
Okay, so what we call, when that happens, when you can't factor this is called prime. Just like the number 13 is prime and it can only be divided by itself, and 1, that's the same thing here.
So what was
No
the greatest
factors.
answer?
Prime.
That's it?
Yep.
Not possible.
15.
Always when it says not possible, it's just prime.
Mhm.
Always. Prime tastes like shit.
15. So looking for a common factor. Boys. Shh. Shh. Okay. Common factor of these 3 terms would be 3. Then I get 5n squared. Why are y'all still talking? I got evidence. Okay, so now it's one of the like harder ones, ACB. 5 times -2 is -10. My B is -9. 2 numbers that multiply to this and add to this would be -10. Uno. -10 times 1 would be -10, and -10 plus 1 would be -9. So from here, 5n minus 10, 5n plus 1. Divide by a common factor if you can. So I'm going to divide this by 5. n minus 2, 5n plus 1. I don't like that this is in first, so I'm rewriting it this way.
After this, can you go back to number 13?
Nope.
Did you have it in a different order?
Here, I'll write it
Like
for
if you had-
This is more proper.
Imagine you still had to guess after doing all that. Oh my god.
Yeah. Normally you start guessing, but. Okay. So that's it for today. You have homework on this on Schoology, so you're gonna take a laptop to your seat, get as much homework done as you can. Harut! What?